everyone, I am Sakshi Kesharwal. I am maths expert in Ask IITians. So today we'll be starting with the third lecture, that is playing with numbers, right? So playing with numbers, this is again I'm saying this in every lecture which I start. This is again the basic of it. You will be learning the basics of it. But to be honestly, if you're going to practice it in a really deep, the concepts over here are totally linked with the concepts of class 7th, 8th, 9th, 10th, right? And it's like that, the same concept, to be honestly, you will see that the same concept will be seen in your class 10th again. But the point is that whether you are understanding this everything over here or not, and the practice of these questions, to be honestly, you'll be understanding the LCM and the SCF. And if you're practicing the word problem of the LCM and SCF at this stage only, then many of the questions, generally this chapter consists of a good weightage, because the questions are really confusing on your school basis also, that you don't know where to find the LCM and what to do with the SCF, whether you have to apply LCM or the SCF, and there's certain criteria of it that you have to memorize, right? So you have to be practicing this chapter, because this chapter consists of a great weightage in all these, in your school examination as well as for your any of the Olympiad. This chapter consists of a good weightage, because it's really tough. It's not tough, but it's, yes, you can, any teacher can make questions which is confusing for you, and you can do a silly mistake, what to do, what not to do. Yes, the difficult questions can be framed from this chapter very easily, and it consists of lots of concepts. There are lots of terminologies, and the terminologies, as I said, the terminologies which you are studying right now, which will be used later in your life all the time. On all your classes, this thing will be used. So let's start with this thing here. Okay, so we'll be starting the third chapter, and really important chapter, because it consists of, again, the important terminologies, and everything is over there. So let's start with it. So here in this topic, we'll be learning wait a minute, let me select pen. Okay, here you will be learning the factors and multiples, prime and composite number, divisibility test, common factors, multiples and co-prime numbers, and the questions related to it. So yes, get started with it. So let's see what are the factors. Factors we have been doing since in class 5th grade, because factors, multiples we have done in your class 5th grade also. So let's little bit fast. Factors of a number is the exact divisor of that number. See what happened, these are the small terminologies, and this you should be keeping in your mind. The factor is a number that is an exact divisor of a number. Let us suppose if I give you a number like 42, right? So 42 have a factor of what? 6 and 7. Yes, and 7 can be other factorized into what? 7, and 6 can be factorized into what? 2 into 3. So let's count out the factors of, for examples, like 42 factors, right? So let's see the factors of 42. Factors of 42 will be what, beta? 1. See, 1 and the number itself, it's always a factor, because 1 is always, if you take any number, that is a 1 divides the number exactly, and if you take any number, the number itself divides the number exactly, right? So you always have a minimum of 2 factors of every numbers which you study, whether it can be integers, it can be a prime number, whole number, or whatever number you see, right? So any number always have minimum of 2 factors. So that is that's 1, and the number itself. So let's see, that is 1. The factors of this is 2, then it have 3, then it have 6, then it have 7, then it have 21, and this have 42. Right? These are the factors. So it means what, if you're going to take any numbers out of this and divide 42, you will see that 42 is exactly divisible. But if I take let's suppose 4, let us suppose if I'll take 4, right? So it's if I'll write the question over here, is it right if I write is 4 is factor of factor of 42? You will say no, because when you're going to divide, answer is what, beta? Your answer is what? No, because when you're going to divide 42 by 4, if you're going to divide 42 divided by 4, your remainder will be what, beta? Your remainder, you will get a remainder, that is, a remainder is 2. So it means what, when you're going to divide any number, you can say like this: if you're going to divide any number, the remainder should be what, beta? The remainder should equals to what, beta? 0. Yes, so any number can have too many factors. Yes, and every number have minimum of how many factors? So we can say that every number every number have minimum of two factors, right? Two factors, right? That will be what that is 1 and the number itself, and the number itself, right? Number itself. These are the two factors which you will always have, right? So if I say what is a factor of 6, so factor of 6 will be what? 1 and 6, definitely. So there is an easy way of finding a number. Like if I say, like if I would have given you like find the factor, like example, if I say find factors of, let us suppose I give you the number like 48. Let's suppose you don't know, let's say what, I'll give you 108. Okay, factors of 108. So let's see. You always have, see, you have to just apply the divisibility rule. So what happened, like factors of 108 will be what? 1 and 108. That is for sure, because the number itself. Okay, now see, this is a prime number. I think so divisibility test also you have done in class 10. So let's do with this. So the number is like 108 is divisible by 2. So if you're going to divide this, it will be what? Divisible by 54? Yes or no, right? So this will be what? 2 and 54. Yeah, check that this is divisible by 3. Yes, it's divisible by 3 also, that is 108. So this will be equals to what, beta? 36. So 3 and 36. This is a way of writing 36. It is divisible by 4. So let's check this is divisible by 4 also. This will be what? 2 and this is 7, right? So you write this is 4 and this is 27, right? Now, this is not divisible by 5. This is not divisible by, let's check this is divisible by 6. Yes, it's divisible by 6 also. So let's see if it will be 1 and it will be 1 and 48, right? So it will be 18. So this will be what? 6 and 18. Right now, let's check that this is divisible by what, beta? This is divisible by 8 again. So this will be what? If you're going to divide this, this will be 12. So you should be knowing the table. Actually, if you know the table of everything, like you know the table till like 10, 12. So you just have to divide it, right? So you see that it is divisible by 8 into 12. So these have so many factors. If you see the number of the factors it have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Minimum, it have 12 factors, not minimum. It have 12 factors in all that is going to divide. There are the 12 numbers which is going to divide 108 into the exactly into, that is exactly it's going to divide. If you're going to take any number, if you're going to take 5 in it, the 5 is not going to divide the factor, right? You will get the remainder in it, right? The remainder will be 3. See, these are the things which I can do easily, but yes, you have to be like keep on practicing all these things. And minimum, beta, you should be memorizing the table till like 15 till 20. You should be like good with the tables like this. It should be on your tips. Then only you'll be like quick. You can do the calculations. Okay. Coming to the properties of the factors, Peter, what are the properties of the factors? As I say that 1 is a factor of every number. True, as I said you, every number is a factor of itself. Yes, if I say that 12, so 1 and 12 will be the two minimum factors. Yes, every factor of a number is the exact divisor of that number, right? So if you're going to take any number, if I say like 12, yes, if I say that is 3 is a factor of 12, it means what? 3 is going to completely divide the 12, means what? You're going to get the remainder 0, right? Every factor is less than or equals to the given number. Right now, it says that 12. How many factors does it have? What do you mean by this? 1, 2, 3, 4, 5, 6. So 12 will have a factors which is like 12. 12 is a big number, right? So it cannot have the factors more than 12. It will have the factors which will be less than 12, right? So let us suppose if you see in the previous slide, 6 have how many factors? It have 1, 2, 3, and 4. So can you see that 6 have like 6 is a fact. 6 is a number, and how many factors does it have? 4 factors. Let's talk about the factors of 3. The factors of 3 will be what? Only 1 and 3. So is it less than the 3? Yes. Let's talk about the factors of 2. It will be, it says that less than or equal to. There is an important word. Let's talk about the factor of 2. What is the factor of 2? It will be 1 and 2, right? How many factors does it have? It have 2 factors. So it is which every factor is less than or equal to the given number. Number of factors of a given numbers are finite. What do you mean by finite? Finite means what? Finite means what? Which is countable. which you can count on your fingertips, right? Which is countable, right? Right now, I said count the factors of 12. You have counted that it is 6. Right now, we did the factors of like 108. You have counted that it is equals to what? 12 factors, right? So what happened? You can always count the numbers of factors. It's not like that the numbers of the factors are uncountable. It can be too many, that is fine, but it is always countable. That you can count on your fingers or not on your fingers. You can count, yes, it's like 100, it's 10, or it's 20. It's like 50 factors. Yes, numbers can have 50 factors itself, but they are bigger numbers, right? So yes, these are the like properties. Please write it down, these properties, and these are very important. You should be knowing these things. The properties are also important because I'm telling you, this chapter is like very confusing. The students, the questions from these chapters have been asked in the Olympiads, whether in class 6, 7, 8, 9, 10. They have been asked like on a worldwide, like, okay, now let's come into the real life examples of a factors. Now let us suppose you have a cake, right? And let's suppose you have a cake and you went for a birthday party, right? You went for a birthday party and you have let's suppose you have a birthday and you have a cake and you want to distribute your cake between like your friends equally, right? Not cake, I'll say like chocolates. Let's go for chocolates, right? So let us suppose you have a chocolate on your birthday, right? Chocolate on your birthday, right? On your birthday. So you have chocolates on your birthday. So let's do the comparison of this part. You have like 12 chocolates, right? You have what, beta? 12 chocolates with you, like 12 chocolates. And you want to divide these among your friends, right? Among your friends, right? Among your friends, right? Among your like 4 friends, right? So how many chocolates will you give to each? How many chocolates will you give to each friend? Yeah, so you will say that, ma'am, let's divide like 12 divided by 4. The answer is 3. So what you did, you divided 12 divided by 4. So 4 is what, the factor of it? Yes or no? Can I write this as how many friends will you like? Spelling of friends. Yeah. How many chocolates will you give to each friend, right? So it will be what, beta? 12 divided by what? It will be what? 12 divided by 3, which is equals to like 12 divided by 4, which is equals to 3 chocolates each. Yeah, 3 chocolates each. So it means what? Can I say that 4 is a factor of 12? That is why you were divided into equal parts or not, right? If I would have said like there were 5 friends, so it will be not, it won't be the exact thing that you will be giving to everyone. Let us suppose if it will be for like 5 friends, then you would be saying that it is divisible into what? 2.4, right? So that is not the exact number. So have I used that 12 can be used as what? 4 into 3, that 4 and 3 are what? Exactly the factors of it. Yes, and you can use this by comparing the prices. Like prices also, like if I say, let's see, these are the things, these are the applications which you have been using into day-to-day life, but you have not taken care of it, right? Application means what? Like cooking or solid food in a different sizes, right? So you know, if you are going to take a big pan and you're going to cook something, it is going to take a longer time or not, right? That is why a small piece of wood have taken a larger surface area to expose the heat, thus they cook faster, right? That is, small piece of wood have a larger, like, so small pieces of food have a smaller, larger surfaces area to expose the heat. Like what you do, like let us suppose this is a chicken, right? So this is a very big chicken and this is a small chicken, right? So they will be like exposed to like greater surface area or not, like it will be more cooked. So these are the things, like it is like a factors only you have to do. Like if you're going to just chop this thing in like whatever, like you're going to cook this big chicken, right? I'm a vegetarian, so I don't know much about it, right? So if you're going to cook this thing and you're going to just chop into this small little parts, so I think so that this is going to take a longer time, because it's like the thing which is getting like cooked inside, it will take longer time. But what happened, what you thought, that if instead of like cooking this big meat or something like that, you just chop this into the smaller part and this got cooked fast, right? Because the thins like it got, I don't know, I'm not very good at cooking and I don't like meat about it. So I think so this is getting cooked fast, right? So what happened? It's like this. What you did, you chopped in such a part that it cooked fast. Yes or no? So what you did, you did the factors of this bigger part to get into the smaller part or not. And this is why you just did it. Like whenever you go on a restaurant, they never give you a big piece of a meat or something like that. They always chop into a small parts and give it to you, right? So what happened, because this take a long, like lesser time to get it like cooked, and they have just chopped it and they have just done a factor so that they can earn it also, right? And comparing the money, right? So let's take an example of comparing money. Let's take an example of comparing money, right? So what happened? If you're going to compare the money, let us suppose you have bought a 36 grams of can of a food at rupees 12, right? And 24, there's a box like canned food, right? Canned food. And for 24 gram of the same canned food, 4 rupees 6, right? No, don't try this. This example is not suiting. Wait a minute. Just a second. Oh, I stopped sharing my screen. Just a second. Wait. Yeah. Let me think. The comparing prices, comparing money. Comparing money, you can just take an example of I said 36 grams into for 12 rupees, right? And 24 grams. Oh. I should write ulta, then I think so we'll get better answer. Let's see. I write 12 grams of canned food. Yeah, canned food is costing rupees 36, right? And I said 24 grams of canned food you're getting in rupees. I'll not write 24. Let's talk about let's make a small thing, right? So let's go with a small example. 6 gram of canned food you're getting at rupees 24, right? Now, which is this is the option 1. Yeah, now this is better. I think so, yes. See, these things you have to think a lot and just say, okay, so this is option 1 and this is option 2, right? Which one is the better option for you? Which one is better? Which one is better for you, right? Which one is better purchase, right? If I ask you like this, so if you go purchase, if you go like this, now let's see, let's go for the purchase one, right? So what will be your option 1? If you see in the option 1, you say that 12 grams you're getting for rupees 36, right? So beta, what will be the cost of it? Says that 12 gram cost you 36 rupees, right? So 1 gram will cost you how much, beta? It will be what? 36 divided by 12, which is equals to what? 1 gram is costing you what? 3 rupees? Yes or no? Let's talk about the option number 2, right? See, this is how you're using this. Option number 2, it says that 6 gram of food it's costing you rupees, how much beta? 24, right? Now 1 gram of food will cost you how much beta? 24 divided by 6. So 1 gram of food is equals to how much beta? 4 rupees. Now, which is the better purchase? Which is the better purchase? 100% this is option 1 is a better purchase, because 1 gram is costing you only rupees 1 gram is costing rupees 3, right? So if you're buying 12 grams. So can you see that these are the factors or not? Right now 36 divided by 12, and you did got the factor, yes or no? So 12 is a factor of 36, and that is how you got the answer, yes or no? So 36 into, that is 12 into 3 is what, 36, and 6 into 4 is what, 24. So can I say, instead of doing such long thing, can I say that 36 can be written as what, 12 into 3? Yes, and 24 can be written as what, beta, 6 into 4. So we can say that 1 gram is costing you what, 3, and here 1 gram is costing you rupees 4. So definitely the option 1 is the better purchase, right? So it's like this, we have been doing such stuff like on a daily basis, how we use those factors and everything, but we don't pay attention. Yes, we are using factors of it, right? So now let's coming to the next question, that is, what are the common factors? Common factors means what? Like I wrote the factors of 12 and I wrote the factors of 16, right? So factor of 12 is what, 1, 2, 3, 4, 6, 8, and factors of 16 is like 1, 2, 4, 8, and 6. What are the common between them? This is 1 and 1. Yeah. So if I'll say like common factors between them, common factors will be how much, beta? 1. Right, it will be 2 and it will be 4. That's the common factor. So we can say that the common factor between these two is what? Later on you will see this, how this common factor will turn into what? SCF. Right, later on you'll be learning it, highest common factor. So can I start it from here? What is the highest common factor between them? First we have found the common factor, right? Now what is the highest among them? Let's do it right now, and later on we'll be doing the same thing, right? What is the highest common factor now over here? Common factor. So the highest common factor between these two is what? 4. So this is the SCF. Later on you will be learning this. This is as SCF. So first you have to find the common factors between all the numbers. So I'll give you example, like find common factors of like 24, 18, and 32. These are the 4 questions, right? So let's write down the factors of let's round down the factors of what, beta? Factors of 24. So it will be what? 1 and 24. Let's leave this space. 2, and this is what, 12. Yes or no? You should know the table, right? This is like 3, and this is what, 6, right? And I don't think so it's getting divisible furthermore, right? That's all? No. 2 and 9. 2, wait a minute, wait, I just, oh my goodness. Yeah, see, I'll write like 1, 2, 3, 4, 6, 8, yes or no? 8, and it's divisible by 12, and then 24, right? These are the factors. Now let's do the factors of 18. So factors of 18 will be what? 1, 2, 3, 6, 9, and then 18. That's all. Now let's do the factors. So you should know the tables, in which tables like these things are coming. So it is 32. It will be 1, 2, this will be 4, 5, 6, no 6, 7, 8, right? No 9, no 10, and then it come into what, 16, and then 32. That's all, right? Because yeah, 1 into 32, this into this. Yes. So what are the common between them? Let's take an example over here. Okay, so what are the common factors over here? Common factors. So common factors are what, beta? Definitely this is going to be 1. 1 is always a common factor between them. Now 2 is the common factor. This is common between these two. Yeah. 2. Now there is no other number which is common between all of them, right? Yes or no? There is no common other factor which is common between them. So can I say what is the SCF of it? The SCF is 2. That's it. 2 is the highest number which is going to which is the common factor between all of these 3 things, right? Now let's do one example. Oh my goodness, this is the same thing, right? All the factors of each of the following numbers, like 125. So this will be what, 1, and then this is 25, 125, right? Now 125 is divisible by what, beta? 5. So this is 5 and this is 25, right? And that's all. So these are the factors will be what, 1, 5, 25, and 125, right? That's all it will come, right? Now let's talk about the 729. 729 is will be what, 1, 729. Let's see that this is not divisible by 2 because this is not an even number. So this is what, 3. So let's do it, like 729 divided by 3. So this is equals to 3, this is 24, 72, and this is 3. So this is equals to what, 243. Now just check If it is not divisible by 2, then it's not divisible by 6, and it's not divisible by 7, then not 8. And let's check for the 9, right? 729 divided by what? 9, right? So it will be 9, so it will be 81, right? So this is 9 and this is what? 81, right? Now let's check for 27, and this will be 27 into 4, no, 3. Yeah, 27. Yes, it will be, because I know this thing very well. Because if you're going to divide 729 divided by 27, you will get 27 into 729 will be equals to what? 0, because it will be 27 into 27. So we'll be just writing 27 once only, right? So what are the factors? It will be like 1, 3, 9, 27, 81, and 81, 243, and 729, right? So these are the factors of it, right? So if you see over here, so your factors will be what? 1, 3, 9, 27, 8, 20. So it can be written as what? 1 into 27, 3 into this, 9 into this, 27 into 3 will be what? 729, right? Okay, now let's see what are the perfect numbers. So perfect numbers are basically what? If you see this, what are the perfect numbers? If you're going to take the the number of for which the sum of all factor is equals to twice the number is called a perfect numbers. See, these are the 4 numbers which I have written for you, and there are from 1 to 100 there are 2 numbers, then from 100 to 1000 there is only 1 number. So these are the things, like if you see what are the numbers for which the sum of highlighter, the numbers for which the sum of its all factors is equals to twice the numbers. If you're going to take the factors of these 6, it will be like 1, 2, 3, and 6. If you just add it, right? If you're going to add, that is the factors of 6 will be what, beta? 1 plus 2 plus 3 plus 6, which is equals to what? 12. So this is what? 2 times the number itself. Yes, so 6 is the perfect number. Next number is what, beta? 28, right? So what are the factors? These are what, beta? Factors, right? Factors of 28 is what, beta? 1, that is 1. It's written over here. 1, 2, 4, 7, 14, and 20. Just add it up. 1 plus 2 plus 4 plus 7 plus 14 plus 28, right? So just add it up. So it will be what, beta? 28, 42, and it will be what, beta? Just added, it will be 56, which is equals to 2 into 20. This is already counted, right? So we say that this is twice the number, this is twice the number. So 6 and 28 are the 2 perfect numbers, and these are generally asked in any of your Olympiad, what are the perfect numbers. So it's better you memorize these 4 numbers, like 6, 28, 496, and 8128. That's all. There are other numbers, you can go and search it on the Google. There are thousands of perfect numbers available, but 4 is till 4 or till 3. If you memorize, that's more than enough for anyone. Nobody asks you these are the perfect numbers or not. If you memorize it, then there is no need to do 6, 28. So if you're going to add it up all, so this is going to be what, beta? 56, which is double of 28. Yeah, 56 is what? Double of 28. So 28 is perfect number. We say 28 is perfect number, right? You can just check for any number. Let's take an example. If you think that 56 is a perfect number or not, let's take the 56. So just factors of 56 will be what? 1, 2. It will be 56. This is 28. It's divisible by 4. So it is 1, 14, right? It's not divisible by 5, 6, and then 7, 8, 9, 10, 7 and 8, right? So if you're going to just add it up, right? So if you're going to add, it will be what, beta? 1 plus 2, 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 8 is how much, beta? 14 plus 8 is 22, right? 22 plus 14 is equals to how much, beta? 14 plus 22 is equals to 36. Yeah, 36, and 36 plus 28 will be 56, and 56, and then plus 8, it will be how much? 64, right? Just a second. Okay, so you just add it up. It will be beta 56 plus 28, it will be like where will be 3 plus 7, 14, 14 plus 8 is 22, 22 plus 14, 36, 36 plus 36 plus 28 will be equals to 64, and 64 plus 56 is equals to how much beta? 120, right? So we see that 120 is not double of 120. So 56 is not perfect square, perfect number, right? Okay, let's talk about the multiples. What are the multiples you have, right? So you see that the multiple of a number, multiple of a number are those which get on multiplying the numbers by any integer. For example, multiple of 3 are what beta? You have to just keep on multiplying with the number like 3 into 1, 3 ones are 3 twos are 3 fours are, right? So you just keep on multiplying, right? So it's like this. You see there are the properties we have, right? Okay. Yeah, you see that multiples of 3. So multiples of 3 will be what? So over here, just see this example. If I write 5 into 4 is equals to 20. So 20 is what? Multiple of 4. It's what? Multiple of 5. And what is a factor of 20? 20 a factor will be what? 1 will be 5 and 1 will be what? 4 or not? Yes or no? So we can say that the factors will always the part of, no. If you multiply any of the two factors, you'll get the answers, right? You will see that it is a multiple of the numbers. Let's suppose if I say a multiply like 6 into 9, right? 6 into 9 will be what, beta? 54. So 54 is a multiple of 3 or not. So if you're going to multiply any of the two factors, if you see that if you're, let's take an example over here. Over here, just see. Yeah, let's take over here. So if you're going to multiply, no. Factors, no. So it says that are those numbers which are multiplying any numbers, right? So if you're going to write this as like multiple of, like if I'll write multiple of 5. So multiple of 5 will be what? 5 into 1, which is 5, right? Then 5 into 2, which is equals to 10. Then 5 into 3 is equals to like 15. Then 5 into 4 is equals to what? 20. 5 into 5 is equals to what? 25. So it means what? To keep on adding. So can I write this as 5, 10, 15, 20, 25, then 30, 35, right? And then dot, right? Yeah, and if you pick any number out of it, like if you're going to pick this number, let's suppose 30. So if you're going to write 30, so 30 can be written as what? 6 into 5. Yeah. 30 can be written as 1 into 30. Yeah. It can be written as what? 2 into 15. Yeah. It can be written as 3 into 10. Yes or no? So can I say that that 2 and 15, 1 and 130, 6 and 5, 3 and 10 are what? Factors of 30? Yes or no? If you're going to pick any of it, yes or no? And can I say that can I say that multiple of 2 will be what? Multiple of 2 you will get as 1 time as 30. Multiple of 15 will be what? 30. If you say multiple of like 1 will be 1 time will be 30. Multiple of 30 will be like again 30. Multiple of 6 will be what, beta? Multiple of 6 will be sometime will be 30. Multiple of like 5 will be what? 30. And multiple of 3 will be again sometime 13. Multiple of 10 will be what? 30. So we say that these are what, beta? Multiples also? Yes or no? Here I say, I'll not write over here. Yeah. So this is basically what? The multiples of the numbers? Yes or no? And we can say that these are the factors, right? So if you pick any numbers, you can always say that this is a multiple of some number or not. If we talk about the 35, 35 can be written as what? 1 into 35, right? So 35 is a factor, is a multiple of what, beta? 1 and 35. Then you can write 5 into 7, that's all. So 35 is a multiple of 5 and that's a multiple of 7 also, yes. So if you pick any numbers, these can be what? Multiples. So can I say that a multiple will be what? A finite or infinite for a number? It will be what? Infinite. Means what? It cannot be uncounted, right? It cannot be counted, right? So multiple of those numbers which get on multiplying the numbers by any integer. So if you take the multiple of 5, you can multiply 5 by like 60 also. This will be how much, beta? 300. Yes. So 300 is also the multiple of 5. Now if I say 5 into like 120, it will be how much, beta? 6,000, yes or no? Yes. So if you're going to take any number out of it, you just multiply with any of the integers that will give you what? A multiple, right? Okay. Now let's see the properties of the multiple. Properties of multiples. Every multiple of a number is greater than or equal to the number, right or not? If let's talk about the multiple of 5. So how many multiples of 5 you got? You just wrote like 1, 2, 3, 4, 5, 6, 7, 8. Just a second, because somebody's calling. Hello. Yes. So see over here. Hello. You just saw that 5 has how many multiples? 1, 2, 3, 4, 5, 6, 7. I just wrote 7 over here, then 8 and 9. So it can be what beta? Greater or not? Yes. Every numbers of multiples of a given number is what? Infinite. This is an important point. It's infinite, right? Every number is a multiple of itself. So can I say that if I write 3, then 3 is what? 3 into 1? 7. Can I write 7 into 1? 35. 35 is a what? Multiple of itself or not? So can I say that multiple of 3? So it's like there is a 1 box. Then you multiplied twice, you got 6. Then you multiplied thrice, you got 9. You multiplied 4, then you got what beta? 12 or not? You just keep on increasing the blocks, you will get what? Multiples or not? So similarly, you'll get the stairs of 3, 3, 3, 3, 3, 3, 3, 3, 3 each or not? Like this, if you see the table over here. So now let's do the illustration. First, two common multiples of like so. With the common factor, we get the SCF. With the common multiples, now let's talk about the common multiple. So let's like multiple of 12. So it will start with what? 12. Then you have to just keep on adding 36 and then 36, then it will be what beta? 48, then 60, then 72, then dot dot dot. Let's write only 5. Then what is a multiple of what beta? Multiple of 18. So multiple of 18 will be what? First is 18, then 36, and you've tried this table of 18, then 54, right? Then 72, and then dot dot dot. It says that first two common multiples. First two common multiple will be how much beta? See, first two common multiple is what? 36. This is a place where the meeting, and the second one is what beta? 72. That's all we needed, right? So can I say that the common multiples will be what? The common two common multiples. Multiples will be what beta? 36 and 72. You can get furthermore or not? Yes or no? Just keep on writing. You can get furthermore. So it will be what? 84, right? This will be 96. This will be 108. Then this is equals to what? 120. So let's write for this again. So it is 18, right? So this is going to be 90 and 108. So you see that 108 is again common. Now, when we write the common factors, so common factor, we take the highest common factor. There becomes the topic of HCF. From here, when you take the common multiple, you get the concept of what beta? From here, you get the concept of what? LCM. What is LCM? It is means what? Least common multiple. Least common multiple. It will be better that you understand over here. Least common multiple. So you just wrote the common multiples. Either you write 5, you write 10, either you write anyone. Least means what? The lowest. What is the lowest over here? The lowest is what? 36. So this is the place where if you're going to write the multiples of 12, multiples of 8, they're going to first meet at what beta? 36, right? Okay, now let's come into what are the prime numbers. As I said that every number have only two factors, right? That is a number itself and the 1, right? So numbers other than 1, whose only factor is 1 and the number itself are called the prime numbers, right? For examples, if you see that 2, it have factor like 1 and 2. 3 is like 1 and 3. 5, 1 and 5. 7 is what? 1 and 7, right? So if I want to write like any number which have only two factors, that's the number and the number itself, right? So as we have said that every number which we study in our life, it will have minimum of two factors. That's 1 and the number itself. And there are some number, they have exclusively only two factors. So if I write like 9, what are the factors of 9? You will say that it will go odd or no. You will write like 1, 3 and 9. So it have what beta? 3 factors, right? This have 3 factors. So not prime number, right? Not prime numbers. Yeah, not prime number. But let's talk about 11, right? So 11 is what? The factors will be what? 1. These are what? Factors. So it will be what? 1 and 11. So this is what beta? Prime number. right? Prime numbers. So I'll give you the homework. Like if you see after 11, what are the like prime numbers you have? Like let's write some prime numbers. You can think patapat in your head. Prime numbers is what? Like you wrote till 7, then you will have 11, then you have 13, then you have 17, then 19. See, this student have 19, then you have like not 21, then you have what? 23, right? I think so, it's hidden over here. It's 23, right? Then you have 29, then you have 31, right? Then you have 33, no. 35, no. 36, no. Then 37. 39, no. Because you should know the table. So is it like 39? No. 39 will not come because 13 into 3 is what? Beta 39. Right? Then you have 41. Then you have 43. Then you have 47. Do you have 51 as a prime factor? No. 17 into 3 is 51. So no 51. Then we have 53. Right? Then we have no 57. Then 59, right? So keep on going. So can you write the prime numbers till 100? Yes, you should remember the prime numbers till 100. Now let's write, let's do it, right? So yeah, that's it. Okay. What do you mean by the twin prime? Twin prime means what? If you take the two primes, two twin prime is a prime that has a prime gap of 2. That is a prime gap. There should be a gap of 2 numbers. You have to take the 2 primes, that's prime 1 and prime 2, and the difference between them is what? 2. Let's see that. Let's take an example. I think so many examples are already written, so there is no need to explain a lot. So let's see, the difference is 2. 5 and 7 is again a prime. Difference is 2. 11 and 13 again a prime. 17 and 9 again a prime. 29 and 31 again a prime, but the difference is 2. 41 and 43, 59 and 61, 73 and 71, right? 103, 101, yeah, 107 and 109, 137 and etc. etc. All right, etc. So you see that the difference between two prime numbers is 2. TWO2. You see that the difference is 2, 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 difference is 2. So these are said to be what? Beta twin prime. Now let's come to co-prime numbers. Please, this is really important. This word comes many times in your life. What do you mean by the co-prime numbers? Co-prime numbers are not the numbers which are prime. Many students just think कि co-prime numbers मतलब क्या कि दो prime numbers. You have to take any 2 prime numbers which have no common factor. No. Please, co-prime numbers, please memorize the definition and know the difference between this. It says that 2 numbers are said to be co-prime if they do not have a common factor other than 1. Let's talk about the 15 and 8. 15 and 8 are not prime numbers, right? But if you write about the factors of 15 and 8, it will be like 1, 3, 5, 7. 5 and 15, it will be like 1, 2, 4 and 8. Now, what are the common factor between them? Only 1 or not? Yes. So I'll say 15 and 8 are co-prime numbers. Co-prime numbers. Yeah. Co-prime numbers. Can I say that 3 and 8 are co-prime numbers? Yes. We say that yes. It's yes. 1 is the only common factor between 15 and 8. So 15 and 8 are what? Co-prime numbers, right? Can I say like 9 and 15 are the co-prime? No, because 3 is common, like 1 and 3 are what? Common factor? Yes or no? So it's no. You can take any pair of 2 prime numbers. 2 prime numbers are always co-prime, right? So you say like, if I write like 1 and 7, yes, they are co-prime. But there are composite numbers also which are like co-primes, right? So see over here, if I write 21 and 25, they both are not co-primes, right? Then no, they're not primes, but they are what? Beta co-prime numbers, right? They are what? Beta co-prime numbers. This is clear. Please, this is really, really important. Please keep this in your head. Very important. Many times there's this thing come co-prime numbers and the students are very much confused with this. Okay. Now, what are the composite numbers? The composite numbers means what? Just the reverse of the prime numbers, right? The numbers which have more than 2 factors, it is known as what? Beta co-prime numbers, more than 2 factors. So like if you take all the even numbers, can you say that example, like all even numbers? All even numbers are what? Beta even numbers, which is like multiple of 2, right? Even numbers will be what? 4, 6, 8, like 10, for 12, 14, 16 or not. So these are the composite numbers written from 1 to 9. All even numbers are what, beta? All even numbers, even numbers except 2 is composite numbers. Are composite numbers? Yes or no? Yes or no? Composite numbers. And we can say one more thing, that over here in the prime numbers, we say, let me write this as a note point over here. This is a note that 2 is only even prime number. Even prime number. Only 2. Only 2 is the only even prime number, and the rest of the prime numbers you see, they are odd. They are not even, right? So we see over here, that is all even numbers except 2 are what? Co-prime number, composite numbers, right? So let's talk about like 4, right? Let's talk about 4. 4 have a factor like 1, 2, 4, right? Let's talk about 15. So 15s are what, beta? 1, 3, 5, 15, right? So it have more than 2 factors, which are known as what, beta? Composite numbers. And the list is already written over here till 1 to 100, right? Okay, so let's learn one more thing over here. Let me see, there are like slide. No, there is no slide. So let's, like, this is important. List of prime numbers till 100. This is important. And you should memorize this, how many numbers are there. So the list will be what? 2, 3, 5, 7, 11, 13, 17, 19, 23, 27, 29, 31, 37, 41, 43, 53, 59, 61, then you have 67, then 71, 73, and then 79, then 80, 81, 82, 83, then you have 84, 85, 86, 87, right? Then 87, 89. 89. 87 and 89. Then you have 91, no, 91, 92, 93, no, 94, 95, 97. That's all you have, right? No 98, no 99, right? Okay, so let's count it out. How many numbers are there? Yeah, so let's count it out. So it is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So in total you have total 25 prime numbers are there till 100. Yeah, till 100, right? Okay, now let's do what are the illustration, right? All the prime numbers between we did right now. Okay, we did all right now. So from 50 to 100, just now we did. So little bit we can be fast, right? So over here you can see the tables are made very nicely. The pictures have been put it over here. So this would be what? 11, 13, then 17, then 19, then 23, then I think so you can do this as HW, please. We have just done not till 100, so I think so it's good to go. Okay, so it's 23, then 29, then 31, then 37, then 41, then 43, then 47. That's it. Yeah, so you just can do this as homework, and the answers are already written, so you can just do. Okay, what is the smallest odd prime number? Smallest odd prime number is the prime number. Okay, one more thing I really want to say as important thing over here. Again, this is important, that 1 is neither prime number nor composite number. Please take this in your head. right? We never say that 1 is a prime number. 1 is neither a prime nor a composite number. As we say to the 0, 0 is neither positive nor negative, because if we cannot give a proper definition to 1 over here. If we consist in the prime number, then it cannot be composite. If we put in the composite, it cannot be a prime number. So 1 is neither a prime number and nor composite number. Please, this is really, really important. I'll highlight this whenever you see the notes. This is important, right? Okay. Okay, what is the smallest odd prime number? The smallest odd prime number will be what? The first part will be 3. Is every odd number a prime number? No. Because 2 is what? 2 is even prime number, right or not? Even prime number? Yes or no? If not, give an example of an odd number which is not a prime number. Okay. Is every odd number a prime number? No. And let's say you will write over here that 9 is odd number, but it is not prime. But it is not prime number, because factors of 9 are what, beta? The factors of 9 are what, beta? 1, 3 and 9, right? So no, it have no, because it have 3 factors, right? Okay, coming to, yeah, 9 is an odd number, right? Which of the following pairs are always co-prime? 2 twin primes? Yes. 2 twin primes are always co-prime, beta. The twin primes means what? They are always prime or not? Yes or no? Let's take an example over here. What are the twin primes? You see that all of them are what? Prime? Yes or no? Yes or no? So yes, it's true. So we have just seen over here. So yes, this is always co-prime. 1 prime and 1 composite number. 1 prime and 1 composite number. No. 1 prime and 1 composite number. Let's take prime number 2 and 4. Always. It says the word always over here. So no. This is prime. Yes or no? And this is composite. Yes? So it's no. It says always, but it's no. Right? Let's take an example of 2 and 16. It's no. Again, no. Right or not? 2 composite numbers. 2 composite numbers, not always they can be prime, right? The one has to be like odd and one has to be like even, right? 2 even number cannot be like prime, and it's like that 2 odd number cannot always be the prime. Like composite, like see over here, like take an example. 2 composite number, let's take like 9 and 27. These are composite number, so no. They have a common factor 9 between them, and 9 and 3. Let's take like 2 and 16. So again, they have a common factor. So 2 composite numbers are always prime. But if you take an example of 8 and 15, we saw that these are composite, but these are co-prime. So it says the word no, right? So over here, you see that if you are going to take 2 odd numbers, it is not necessarily that they are going to be what, beta, prime. But let's take an odd number like 9 and 25, right? These both are what? Odd. These both are what, beta? Odd. But they are what? Co-primes? Yes or no? Yes. But if you're going to take any 2 odd numbers, 2 even numbers, 2 even number can never be composite, right? You take any 2 even numbers. Let's take like 16 and 28. They will have a common factor 2 always between them. So 2 even number cannot be co-prime always, but 2 odd numbers can be co-prime. 2 composite numbers can be or cannot be co-primes. Yes. 1 odd and 1 even can be a co-prime, yes or no? And like for 2 even numbers, they can never and ever be a co-prime numbers, right? So the answer is no. Okay, it says that express each of the following sum as the sum of 2 odd primes. Read out the word 2 odd primes. 2 odd primes. So just you have to think of the prime numbers in your head and please memorize the odd numbers. So 36 can be written as the sum of what, like prime number 29 plus 7. Yes or no? These both are odd. 42 can be written as like 23 plus 19. Yep. 23 plus 19. Yes or no? You just add it up. It will be like odd. 84. Hmm, 84. 41 plus 43. Yes or no? 41 plus 43. Right or not? So, that's all. 6 this can be written as or 17 plus 19. This is also can be written. Yes or no? So can you see that a pattern is formed or not? Like you can see that a pattern is formed. You have to just half it. But yes, do the half of it, right or not? And this can be written of like if you take any number, right? But all the numbers cannot be written. So you see that it says that write as the product of the two primes. So what I did just half of it, like 84 divided by 2. It will be like 42. Then what I did, I subtracted 1 and then I added 1. So this is like 41 and this is like 43. So you got the sum, right? It says that 42 can be written as what divided by 2. So this is equals to what 21. Then what I did, subtracted. Yeah, it's not the pattern always formed. So it's like that subtracted 2 and then I got subtracted like added 2. So you got like 19 and 23. So I just did the half and like somehow I got the answer. So there's anything can go in your head, right? So there's no specific pattern form, but yes, this is what I was thinking and I got the answer, right? So if you see for the 36 divided by 2, so it will be what 18, then it will be what subtract 1, then subtract plus 1, it will be what 17, and then I got 19. Yeah, so there's no specific rule for it. So you can just opt any of the like specific thing that you can get for it. If you're going to subtract 1, it will be 20 and add 1, it will be 22. So they are going to be odd. No, it won't be, right? Yeah, so let's see, 84 can be written as what 17 into 67. Yeah, 5 into 37. 7 into 29. See, there are various ways of writing these numbers. So what came in my mind? My mind just while I just saw this question, I did in this way, right? You can do in any of the way you feel like, right? So let's come into the test of divisibility of a number. Test of divisibility of a number. We say that every or even number, right? What are the even numbers which have like at the end like 0? Okay, it says that the divisibility of 2. Okay, it says the divisibility of 2 means what? If there is any even number always end with what? 0, 2, 4, 6 and 8 as the end of the digit when it is divisible by 2. If you're going to take an example of like 1, 2, 3, 4, 7 and 8. Is this divisible by 2? Yes, it's divisible by 2. So you have to just check the last digit number, that is it an even number or not? That is 0, 2, 4, 6 and 8. Yes, it's divisible by 2. Take any number, right? Now it says that the divisibility rule of 3, any number which is divisible by 3 if the total of all the digits sum, that is a multiple of 3, right? If I write like 243, right? So you just add it like 2 plus 4 plus 3, which is equals to what, beta? 6 plus 3, which is equals to 9. And this is what, beta? Multiple of 3. Multiple of what, beta? Multiple of 3. So yes, it's divisible, right? Yes or no? Let's take any number like 93. Is this divisible by 3? Yes. So you are just going to add 9 plus 3, which is equals to 12. 12 is what? Multiple of 3, right? Multiple of 3. So yes, it's divisible, right? So you have to just add the digit and see that it is divisible by 3 or not. You see that the divisibility rule of 4 means what? That the last two digits should be like divisible by 4 and it has to be what? Even, right? Even number, like any number is divisible. Okay. What is the date today? Okay. It says that, so we have to check whether the last two digits of a given number are divisible by 4 or not. If it is divisible by 4, then the whole number will be what, beta? Divisible by 4. Let's take an example for it. I just changed the slide. Let's take an example. I'll write like 4, 3, 8, 7, 3, 2. Just check. Is this divisible by 4? Just check. You have to just see. I'm not saying what will be the answer, what will be the question. You have to just check divisible by 4 or not. Divisible by 4 or not, right? So what you have to do, you have to just check the last two digit number. Is 32 divisible by 4? Yes. So yes, it is divisible. Yes, it is what? Divisible, right? It is divisible. That's it, right? Now, similarly, what is the divisibility rule of 5? Divisibility rule of 5, any given number will be divisible by 5 if the last digit is 0 or 5. If the number is like ending with 0 or 5, it will be divisible by what, beta? 5. Yes. So if I'll write like, for example, like 3, 2, 5, 7, 1, 0, and I'll write like 1, 2, 4, 5, 5. Is this divisible by 5? Yes, and this is yes. Without, you have to just check whether it's divisible or not. Yes, because it's ending with 0 and it's ending with 5. That's it. Okay. What is the divisibility rule of 6? Beta 6, if you see that, what are the factors of 6? Factors of 6 are what, beta? 2 and 3. If the number is divisible by 2 and 3, then it is definitely going to be divisible by 6. That's definitely for sure. Later on, we'll see that how I say such stuff, right? So if you see this, if you see that any number will be divisible by 6 if it is divisible by 2 and 3 both, not one by them, it should be divisible by 6. So we should do the divisibility test of, just a second. Yeah, can you see me? Okay, so you see that, so that you have to perform the divisibility test of 2 and say that the answer is divisible by 6 or not, right? So if I give you one example, like, okay, if I give you the example, example is like, check 7434 is divisible by 6 or not, right? So what you have to do, you have to check divisibility by 2. Yeah, so it's yes, because it's even, so it's a even number, right? So divisibility by 3, so just check the divisibility by 3. 4 plus 7 plus 3 plus 4, it will be how much, beta? 10. And this is what? 18. 18 is what? Multiple of 3, right or not? Multiple of 3, right? So it is yes. You have to just check. It doesn't say what was the answer. It says that just check whether it's divisible by 6 or not, right? Now it says that divisibility rule of 9. Any number which is divisible by 9, it should be what? Total of what? The total sum of the digits should be divisible by what? 9. So please, student, many of you get confused that divisibility rule of 9 and divisibility rule of 6, right? So if I say like check number is divisible by 9 or not. Yeah. So if I give you, let's take a small number like 24 and I write like 27. Just check at the number. So it is 2 plus 4, which is equals to 6. And this is 2 plus 7, which is equals to 9. So it is what, beta? This is what? Multiple of 3. This is what, beta? Multiple of 3. Right? So it is what? Divisible by 3. It is what, beta? Divisible by 3. Right? But over here, this is what? Multiple of what? Multiple of 9. It has to be what? Multiple of 9, and it is a multiple of 3 as well. So 27 is divisible by 3, that's for sure, but it is divisible by 9. It is divisible by both 3 and 9, but 24 is only divisible by 3, not by 9. So it is divisible by 3 and 9, right? But we say that it's a multiple of 9, so yes, it's for 9, definitely 9 for yes, 3 it's like definitely, but for 9 you have to be very specific that it has to be the multiple of 9, not of 3, right? See, 3 may you see that right now you got 6 as the answer. If you say, I give you an example, 15 is divisible by 3. If you're going to add the digit, 1 plus 5 is what? 6 is a multiple of 3, so 15 is divisible by 3. But can I say that 15 is divisible by 9? No, because you're going to add 1 plus 5, which is equals to 6, which is not the multiple of 9. So if any number is a multiple of 9, it's definitely going to be divisible by 3 plus 9. But if the number is divisible only by if the number is like, if after adding the sum, if it's a multiple of 3, so it means what, it is just going to be what, beta, divisible by 3 only, right? Not by 9. Okay, what is the divisibility rule of 7? This is long. I don't prefer this one, but it's okay. Okay, so it says that any given number which is divisible by 7, if we double the last digit of the number and then subtract the result from the rest of the digit and check whether the remainder of the digit is divisible by 7 or not. If there is a large number of the digit, we do the repeat process until we get the number could be checked by divisibility rule of 7. So I'll give you the number like I'll give you like, let's a big number. Okay, it's C over here. Just example is check divisibility. What does it mean? Like, what the big statement mean, right? Divisibility by 7, right? So it says over here, I wrote the number like 17213, right? It says that if we double the number, let's take a small example first. I'll take a small example that will help you, right? Wait, I'll take a small example, right? That will help you to understand, and I'll go with a big example also. For example, just question number 1, it's 343, right? What do? You double the number, like double the last digit. So it will be what? Double is what? 6. Double of 3 is what? 6. Now, what do you have to do? 34 minus of 6. What is your answer? 28. Now 28 is what? Multiple of 7. If you know the answer, then it's good, right? So this is what, beta? Multiple of what? Multiple of 7. So yes. So yes. Now let's do with a big number. Let's check with the question number 2. I wrote 17213. So what do? You double the number, right? Double of 3 is equals to how much? 6. So it is what? What you will be doing? 17211 minus of 6. It will be what, beta? 1715, right? So it is what? 1715. Right now you don't know that it's divisible by 7 or not. What do? You do the double of this digit, right? Double of 5 is 10, right? So what do? 171 minus of 10. So this is equals to what? 161. Yes or no? So like still you don't know that 161 is divisible by 7 or not. So what do? Do the double of 1. I don't like this method, but it's okay. Double of 1 is what? 2. So what you'll do? 161 minus of 2, which is equals to, my bad. It's 16 minus of 2, which is equals to 14. So you, at the end, you got 14, and you know that this is multiple of what, beta? Multiple of 7. So yes, is this divisible by 7? I don't like this method at all. I don't like this method, but yes, for a bigger number you can go for it. Like for examination, when there is a like the numbers are there, then you can just go for this, like little bit you can just go for it. Now what is the divisibility rule of 8? Divisibility rule of 8 says that we check the number that is last 3 digit of the given number is divisible by 8 or not. If it is divisible by 8, then the whole number is divisible by 8, right? So let's take an example for this. If I'll write like 1, 4, 8, 3, 2, 1, 0, and 8. I'll write not. I'll write like this. No. I'll write this. 512. Yeah. So just you have to check that 512 is divisible by check. 512 is divisible by 8. Yes, this is divisible. So the entire number, yes, it's divisible. Yes or no? 8 6 and then you get 3. This is like 6 and 64. Yeah, 64. Like you get the answer. So entire number is entire spelling is wrong. Entire number is divisible by 8, right? Now let's check the divisibility rule of 10, right? So what is the divisibility rule of 10? It says that any number which is divisible by 10 have the last digit as 0. You write 10 zeros, you write 1 0, it is going to be definitely divisible by 10, right? So for example, if I write like 4310, yeah, so this is divisible by what, beta? 10. Yes. And it is divisible by 5. Yes, that's all. Yes. But if I write 4315, it is divisible by 5. Yes. But 4315 divisible by 10 is no. So the number ending with like divisible by 10 should end with what number? 0. Right? Let's coming to the divisibility rule of what, 11, right? So again, this is a big number and this is really important. This one is important, right? This one I'll write it important because sometimes many questions are asked on this question, like this 3, 9 and 11. They generally ask you. So it says that find the difference of the digit sum at the odd places, that is from the right, and the sum of the digits of the even places from the right of the number, and the difference is either 0 or 11, then the number is divisible by. So you wrote the number over here. Just see, you can just see the example over here. It's divisible by 11. So you're just going to add like odd places. Like, so you have to start from 1, 2, and then 3. These are what, beta? These are even, right? No, this is odd. This is odd. This is odd. This is odd. Odd, odd, odd. From the right, right? This is odd. Let me change color. Okay. And this one is what, beta? Even. Yeah, so what you have to do, just add the blue color one. So blue color one will be what? 1 plus 3 plus 3 will be equals to what, beta? 8. And then you have to just add 2 plus 4 plus 4 is what? 8. So it is what? Is divisible by what? 11. Let's do one more example. Okay, it says that 27049, right? So see, I'll just write this 1 and 2. Let's take the even places. So it will be what? 9 plus 0 plus 2 is how much, beta? 11, right? Now let's take the odd places, right? So it will be what? 7 plus 4 is equals to what? 11. So 11 minus 11 is equals to 0. So yes, it's divisible, right? It has to be what? Multiple of 0, or it has to be 0 or multiple of 11, right? Now let's do the list. A list consists of the following pairs of the numbers. Categorize them as a pair of co-prime, prime, and the composite numbers. So what are the co-prime numbers? This one is co-prime. This one is again co-prime. This one is again co-prime. Then 63, 65 co-prime. Yes and yes. Everyone is, because everything is like twin primes. Yes. 59. This is not twin prime, right? 55 and 57, right? So here, this is prime, this is prime, this is not prime. 63 and 65 are not prime. So let's take, I think so instead of writing this as a co-prime, all of them, 51, 53, 55, 57, 69, 63. So all of them. Yeah, primes, right? Primes will be how much? This will be like 51, 53, right? Then 59. Then 61 and 61, no, 59 and 61, then 63, no, 63 is not a prime number, so it will be 67, 69, 71 and 73. What are the composite numbers over here? It will be what? 55, 57, yes, 57 and 63 and 65. These are what? Composite numbers, right? So yes, now it says that in each of the following number, replace a star by the smallest number so that it is divisible by 11. So it's straight like 9 star 8 0 7 1. So let's go from this, then this, right? So odd places it will be what? 1 plus 7 plus star. Right, let's go for the odd even places. This plus this. So it will be what? 9 plus 8 plus 7. So 15 is equals to, this is equals to what? 8 plus star, right? So this is equals to 15 plus 9 is equals to what? 24. So what we have to do? Difference. You have to take the difference. So 24, I'll take like this. Instead, I'll write like this. Take the difference because you have to keep this in star. So 8 plus star minus 24 is what? 0 or multiple of 11? Yes or no? So this is equals to it is minus 16 plus star. No. Am I taken right or not? It is 1. I wrote it like, oh my goodness, I did it wrong. Calculation. Wait a minute. That is what I was thinking. Something is wrong. Yeah, there's something wrong. This CO here. It says that 1 plus 0 plus star. So it is 1 plus 0 plus star, which is equals to what? 1 plus star, right? And you have 7 plus 8 plus 9. This is 9, right? So you have even places, 7 plus 8 plus 9. So it will be 9 plus 8 plus 7. Right? So this is equals to what? 15 plus 9 is equals to 24. Okay. Yep. Now you have to take the difference. Difference is you just take 24 minus of 1 plus of star. So this is equals to 23 minus of star. Yeah. So you have to put, it should be what, beta? Multiple. I'll write it like this. Yeah. This is like 24 minus of 1 plus of star. It should be what? 0 or multiple of 11, right? Multiple of 11. So this is equals to what? 23 minus of star is equals to 0 or multiple of 11, right? So you cannot take star as 23 because you have to take star as what? Star is a single digit. Yes or no? Is a single digit number? Yes or no? Single digit number. So multiple of 11. So you cannot take 0. So multiple of 11 will be like 22, right? So star can be what? So star can be like 23 minus of 1, which is equals to what? 22, which is equals to what? Multiple of what? 11. Yes or no? So star is equals to what? 1. Yes or no? And if you go to on 11, so you have to what? Subtract how much better? You have to subtract 12 from it, right? So it will be again a 2-digit number. So star is 1. Yeah. So the smallest number is what? 1. See over here, let's do the statements true or false. It's going to be a very big question. Yeah. If a number is divisible by 3, then it must be divisible by 9. As I told you, it's 15 is divisible, but 15 is not divisible by 9. So it false, right? Okay, if a number is divisible by 9, it must be divisible by 3. Yes, it's true. I told you right now, if the number is multiple of 3, 9, it's 100% divisible by 3. So it's true. I told you right now. Okay, if a number is divisible by 4, then it must be divisible by 8. Not necessarily. Let's take an example of like 12, and 12 is not divisible by what? 8. Yeah. Take a simple example, not divisible by 8, so false, right? But if you say that if a number is divisible by 8, it must be divisible by 4, yes, it's true. Yes. So the bigger number, if the number is divisible by the bigger number, then the smaller number is definitely going to be divisible, because you can say that 3 is a factor of 9, 4 is a factor of 8. So yes, if a number is divisible by 8, it's definitely going to be divisible by what? 8. Yeah, true. If a number is divisible by 18, then it has to be divisible by both 3 and 6. 3 and 6. Let's take an example of 18. Multiple of 18. 18, 36. 36, then you have 54, 72. If a number is divisible by 18, then it has to be divisible by 3 and 6. Yes, it's true. It has to be divisible by 2 because 3 and 6 are its factors, so it has to be divisible by 18. 18, but it's false. Let's take an example. 90. Yeah, 90 is divisible by 6 also. It's true. Okay, let's take an example. If a number exactly divides the sum of the number, it must exactly divide the number separately. If a number exactly divides the sum of the two numbers, this is what beta. If a number exactly divides the sum of the two numbers, it must divide. So let's do the 7 part over here. It says that if a number exactly divides the sum of the two numbers, like it's like 4 plus 5 is divisible by 3, which is equals to what? 9 divisible by 3. Yes. So if I say, can I say that 4 plus 5 by 3, they are divisible separately? So it's no. So this is false, right? If a number divides three number exactly, it must divide their sum exactly. If a number divides three number exactly, if a number divides three number exactly, let's take the 8th part. If a number divides three numbers exactly, so let's take an example of 16. It must be divided by their sum exactly. Okay, let's take an example of like 16. If a number divides three number exactly, okay, so three number exactly. Okay, yes, it's true. Let's take an example of 4 divided by 2. Yes. 6 divided by 2. Yes. And then 8 divided by 2. Yes. So can I say that 4 plus 6 plus 8 is divisible by 2? So this is equals to 10 and then 18. 18 divisible by 2. Let's take an example of 9 divided by 3. 6 divided by 3 and 12 divided by 3. So just add it up. So it will be 9 plus 6 plus 12. Is it divisible by 18 plus 27? So yes, it's true. Yeah, it's true. Okay, if a number, if the two numbers are co-prime, at least one of them must be a prime. It's false. We just learned that is 8 and 15. Yeah, it's false. We just learned that is 8 and 15 are what? Though both are composite numbers, but they are co-prime as well. The sum of the two consecutive odd number is always divisible by 4. Sum of two, let's do the 10th part. 10th part over here. It says that the 10th part, that is the sum of two consecutive odd numbers. Consecutive odd numbers, let's take like 7 plus 9. It's equals to 16. Yes. Yes. Acha, let's take 11 plus 13. It's divisible by 4. Yes. Yes. Okay. Let's take an example of like 21 plus 23. So it's 44. It's yes. So yes, the answer is what? Yes. It's true for all the numbers, right? Consecutive, it has to be the consecutive odd number. So answer is what? True. So this is also a result. The result is what, beta? That is, if you're going to add any two consecutive odd numbers, it will be always divisible by what, beta? 4. So yes, the answer is true. So we have done this thing, and I think so this was a very, very big lecture, and later on this is also going to be a big lecture, and I hope you have understood this topic very well till now. Please do the revision and ask if you have any doubt, please ask your doubt on the PDF and ask this doubt with your respective teacher if you have it. And thank you class so much. Bye-bye, beta.